Hi everyone, this is Mrs. Martinez, and in this section we are looking at graphing inequalities. This is from the BJU textbook, Chapter 2, Section 6. So let's get started. What you as a student will be able to do, or want to be able to do by the end, is graph linear and absolute value inequalities. In addition to this, you want to recognize that inequalities are relations but are not functions. So let's get started. Graphing linear inequalities. When you're asked to graph linear inequalities, you're going to want to carry out a process of steps. And so we're going to walk through those in this nice diagram. The first thing that you need to do is solve for y. After you've solved for y, you want to graph using the slope and your y-intercept. This is going to be a lot like graphing equations in the Cartesian plane. We're just going to do a couple extra things. So up until this point, it should feel very much like what you've been doing, graphing lines. But you have to ask yourself, is this going to be a solid line or a dashed line? It will be a solid line if your inequality has the equal included in it, like greater than or equal to, less than or equal to. You'll draw a solid line. But if you have strictly greater than or strictly less than, when you graph, your line is going to be dashed. It won't be solid. So this is our first difference from the kind of graphing we've done thus far. After you've drawn your line, whether it be solid or dashed, then you're going to shade. You're going to shade above your graph if it's greater than or equal to. And you'll shade below your graph if it's y less than or y less than or equal to. So that's something new, different from what we've done before. So, something I want to remind you of is when you're working with those constant functions, like the horizontal line, you're always going to graph a horizontal line if it's y equals. And you'll have if you have a vertical line graphed, it's because your inequality was x greater than or equal to some value. So why don't we work through this example together here? We have 2x minus 3y is less than 12. So our first step is to solve for y. To do that, you would subtract 2x from each side, and then you would try to get the y by itself by dividing everything by -3. Now, in your notes, I want you to draw a little thought bubble. When you divide by a negative, or when you multiply by a negative, your inequality is going to reverse directions. I'll say that again. When you divide or multiply by a negative, your inequality symbol is going to reverse directions. Therefore, now it's going to be y values greater than, and you had negative divided by negative, that makes it positive 2/3 x, and a positive 12 divided by that -3 is -4. Do you see how the inequality symbol changed directions? That is because we divided by -3. All right, now we're going to graph using our slope and our y-intercept. Our y-intercept is our b value. It is -4, so I've plotted that point on my graph. And then the slope tells us how to move. We're to go up 2 over 3. Up 2 over 3. All right, so that kind of is going to give us a structure for how to graph our line. We need to figure out, is it a solid line or a dashed line? This is going to be a dashed line because it is strictly greater than. And now we're to shade. We're to shade above because our inequality symbol is greater. Oh my, it didn't show the graphing. You would go ahead and shade above there. All right, so now here's another one that we're going to work through. First step again is to figure out, well, to get your y by itself, to put it in that slope-intercept form so that you can graph. So we're going to move that 2x to the other side by subtracting. Now we were just subtracting, so the sign did not change directions. Now, what do we know? We know that our b value is 5 and our slope is -2. You could think of it as -2 over 1. Rise over run. Now we can plot those points. Our intercept is where we begin our b value at 5, and then we're going to go down to over 1 because it is a -2 over 1. Look carefully at your inequality symbol. There's another point just to kind of help make it a little bit nicer line. Looking at your inequality symbol, it is equal to, so our line is going to be solid. And we're asked to shade y values that are greater than. So greater than means we're going to shade above our line. Now, the way I like to think about this, look at where your line crosses your y-axis. Do you see how the y-axis has been split in two? You have values greater than 5 and then all the y values that are less than 5. We need to shade the part that is above. That would be all of this area here. We've divided our coordinate plane really into two sections, and we want to shade the section that includes the part of the y-axis that is greater than our graph, greater than our line. All right, we have another one like this, so let's get ready and go. You could challenge yourself right now if you're feeling pretty confident. Pause the video and try to graph this linear inequality, and then we'll check it together. But if you're still wanting a little bit more instruction, I'll begin in just a moment to give that instruction. But if you're ready, you can pause the video and try it on your own. All right, our first step is to get this linear inequality in the y equals mx plus b form, to get y by itself. To do that, we're going to first subtract the 4x from each side because it was currently a positive 4x. Now the last thing we need to do to get y by itself, y is being multiplied by -3. It's -3 times y, so we have to do the opposite operation, which is dividing. We're dividing by -3. Because of that, the sign changes directions. Negative over negative is a positive 4/3, and a positive 6 over a -3 is a -2. Now we have it in the form that makes it easy to graph. We know that our y-intercept is -2. It is our b value. It is where we will begin. And our slope is 4/3. It is the value in front of x. It is our m. It's telling us how to move from your beginning point. So we're going to graph our beginning point, our b value at -2. And then we're going to move rise over run, rise 4, run 3. Rise 4, run 3. Our inequality symbol is a less than symbol. Because of that, we're going to have a dashed line because we're not going to include the points that are on the line. That's why it is dashed, to kind of symbolize that those points on it, on that line, are just boundary points. And notice that your coordinate plane is split into two parts now. The part above and the part below your line. And we want to shade y values less than, which is going to be this section here. It's including the part of the y-axis that is less than your line. And those are examples of linear inequalities. What we're going to work on next is absolute value inequalities. So in our last lesson, we looked at graphing absolute values, equations. Now we're just going to take what we just saw, working with inequalities, and apply them here as well. So looking at this graph, we have to remember we're looking at y values greater than the absolute value of x minus 2 plus 1. We have to figure out, okay, how are we translating the parent function here? Well, we would be translating it by moving right 2 units because we're subtracting 2 inside of the absolute value bars. And we're going to move up 1 unit because of the plus 1 outside of the absolute value. This line is going to be, what is it going to be? Dashed or solid, guys? What do you think? It's going to be dashed because it's strictly y values greater than. And notice that I've moved my inequality, my absolute value graph over to the right 2 units and up 1. Now the last thing we need to do is shade. If you don't shade, it's really not an inequality that you're working with. We're going to shade y values greater than the graph, which is going to be up here. If it would have been less than, it would be all of that white space that currently is not shaded in. All right, we're looking at our last example. It is once again a absolute value inequality. If you want to pause the video here and try to graph this one by yourself, I would encourage you to do that. But if you need a little bit more guided practice, then just hold on a moment and I can walk you through it here. All right, we are looking at translating this graph. How was it changed from the parent function? Well, you have a plus 2 in there, which means you're going to move left 2 units. And you've subtracted 3 outside of the parentheses, which is going to bring your graph down 3 units. So the vertex of this graph, that turning point, is going to be left 2 units and down 3 from your origin. Okay, but before we graph this absolute value that looks like a V, we need to know, is it going to be dashed or is it going to be a solid line? Because it's really irritating to go and draw a solid line and then realize it should have been dashed. So looking at your symbol, because it is a less than or equal to, this is going to be a solid line. So we're going to sketch that out. Solid line. Each of these lines has a nice slope, up 1 over 1, up 1 over 1, creating a nice V shape. It's moved down 3 units and to the left 2 units. What you're looking at right now is an absolute value equation. Now, to make it an inequality, we are going to have to shade according to our symbol. It is y values less than, which means we're going to shade the area that is below our graph. Right in here.